Welcome all. Today we are going to see that the resolution part. So first of all, resolution, this is one of the important technique in the AI concept. So resolution means this is one of the important inference technique. It mainly used for the solving the logical problems and then the theorems, for example, etc. So here the resolution mainly focus on solving the FOL to the CNF form. So before going to solve this the thing, so we can first justify like main the definition is what is mean by the resolution. So resolution, this is one of the logical method. It mainly used to validate the statement by assuming the negation function within the contraction level. So what is meant by the contradiction? So contradiction means what now? This is one of the incorrect statement. Whatever the incorrect statement, it will be there. So we can take just negate with the false rule. And then original statement is there now. We can consider as a true function. So this is one of the powerful reasoning for solving the logical and mathematical functions over there with the help of FOL function and then CNF function. So basically the resolution, this is one of the logical form. It should be validate like the true case and then false case. But whenever the statement is getting like the true means, so oppositely we are going to observe. Okay, so that is the thing. So opposite reaction, it will be mainly take with the contradiction method only. With the help of the contradiction, so we are going to prove like the true and false statement over here. So before solving this problem, so we are having the four steps. The first one, step one, so we are having the proper statement. That statement, it should be converted into the first order logical form. So that is the implies, so particular statement what the thing is going to insist or connect, so that the help of only we are going to make with the first order logical function. The after the step one, so we want to just make with the FOL statement convert to the CNF form, that is a conjunctive normal form. Okay, so this or else we can call it as a clash form. So conjunctive normal form means, so how we are going to take now? So we are having the four kind of the steps follow here. So the first one, removing the implications. So we are having the statement, we should just follow by the negation rule. We should just apply for the negation rule. Maybe we can consider as a true statement. It will be always take about the false statement over here. The next consideration is Morgan's law, De Morgan's law. So the moving the negation here. So we are having the negation of the rule in the outer layer of the context or variable. But this statement, it's going to connect with the each and every variable with the opposite function. Here negation bracket A for all B. Here we will get after the Morgan's theorem negation A and negation B. So this is the rule number one. Maybe if we are going to get the and means, so what the thing is happening means negation of A and for all negation of B. So this is one of the moving the negation inward using with the help of the Morgan's law. The next one is as the negating quantifier. Negating quantifier means, so we are having the rule, but the totally it will be just negation could the somewhere. For example, for all we are getting, but here we should just taking like the there exist. So equally it should be tallied. Okay, so here we got the negative of the for all, but here we will get like the what is that? The there exist of the x. Okay, and here we don't have a negative, but here we will get the like negation of the p of x. The other rule is there exist of the negation, but we will get like the for all of x. That is the opposite rule, and p of x we will get the negation of p of x. And the double negation. Double negation, the thing doubly we will get, and the double a we will get the without the negation rule over here. So this is the rule number two. And next one, the next type is standardizing variable. The standardizing variable is going to observe like the rename of the variable, because why we need to just avoid the some confusion category, or same variable it will be occur repeatedly, so it will be going to making as a very what is that some confusion manner for solving the problem, so we cannot able to get the good outcome. That's why we can apply with the standardizing variable. So standardizing variable, what does in the thing means, so we are having the statement here, but what is the statement we are having? For all x, p of x, for all there exist of x, x. So repeatedly we will get the x as the common variable here. But here also for all there simultaneously there exist also there. So we cannot able to find so which kind of the variable it will be going to finalize. So that in this scenario we are going to just connected with the rechange with the or rename with the other variable here. For you can look at here for all x, p of x, and for all, so here we want to change with the replacement of y. Okay, so what the thing is happening there for all x, it will be connected to the one of the function, and there exists y, it will be connected to the one of the function rule. So this is called as a standardizing variable. We should avoid the repeating or what is that? Same name it will be occur means we can apply for the standardizing rule, and we should avoid the confusion like the repeating variable of the confusion matrix. The next one, applying the scolarization method. Scolarization method means we can remove the existential quantifier. Okay, so this method we can call it as a scolam function or constant. Okay, the scolarization for process, it will be just generally or taking with the existential rule. So we want to just replace with the existential method. So we can look at the example. This is the example. So for all there x and there exists of y, p of x dash of y. So the main rule of this column. So what the thing it will be doing means, so we can remove the existential quantifier. So there exists with the variable we need to avoid it. Okay. So that there existing, what is the connectivity of the variable here? Y is the variable. So what the thing we should do? We can remove the y in the p of x also. In replacement, we can just make with the function of x here. Okay, so that's why the column rule, it will be connected to the functions or constant. Any one of the thing we need to just add within the wherever the variable is moving, we should just add it here. Okay, so finally we will get therefore all x and p of x dash f of x. Understood? So this is called as a column rule or scolarization rule. Okay. The next one, drop universal quantifier. What is meant by the drop universal quantifier? So we are having the lot of variable over here, but we need to just avoid the for all in the particular statement. So that's why it depends upon the condition, we should just make with the universal quantifier over here. The next one, after following this process, okay, so whatever the statement, it should be comfortable for solving that resolution part. We can make with the other statement or possible way of the statement. So after the step 2, we can directly go with the step 3 process. Okay, so step 3, what the thing is saying here means, as a goal state, we are going to prove the one of the statement over here. So negate the assertion of the goal. Okay, we want to make with the negation rule whatever the proof is there. So we can make with the opposite rule condition. The next one, fourth step. The fourth step, we want to just make with the some draw of the resolution. Okay, we want to make with the some resolution part of the graph. Okay, so these things only happening here. So after this process, so now we are going to see that the sample structure of resolution here. Okay, so what the thing is happening here? So this is one of the rule. So directly they have given the FOL form. Okay, AB, A to B, and then B to C, and then A. This is one of the FOL form here. Okay, what the thing we are going to do? So first, after the conversion, first this is the first step, this is the second step, this is the third step, this is the fourth step generally. By directly in this example, they have given like the FOL form. Okay, so no need to worry about that. So now we can able to solve with the second rule now. Okay, that is a conjunctive normal form. What the thing it will be going to do now? So first one, so check with the first rule, A implies the B. Okay, so what the thing we want to make with, that is a negative rule. The negation of A for all and then B. Okay, that is a OR rule. And the next rule is B implies to the C. So negation of B for all, that is a OR condition, not a for all, OR condition, and then C. And finally we will get the A. Okay, so this is the conversion of the conjunction form. After the conversion or conjunction form, like we can just do with the negation rule. What is the proof here? The proof we want to prove the C. Okay, the negation rule is negation of C. So this is the third rule. And now we want to just make with the draw of the graph only, we will get the proof of the rule here. So after the negation, we can just take with the negation of C. Now we want to check the where the C is present in the statement after the conversion of conjunction form, CNF form. Where is the C is present? First statement, well, we don't have a C, and second statement we are having the C. So we can just write negation of B for like or and then C. So now we want to just cut the negation rule of the C and then normal C. Now we have only the negation of B. We want to take the second step for the negation of B here. Now we want to check where the B is present. So already this second rule is over. We are having the two rules only, this rule and then this rule. So first we want to check the first rule. Okay, so here a negation A for all of B. Okay, so we just write like that. Okay, so now we want to cut the negation B and then B. So finally we will get the negation of A. So negation of A, so we are just focus in the A rule. So for only one rule only we are having. So A we can write and then cancel with the negation. So finally we can prove like the negation of C as a final statement over here. So this is called as a resolution. The main resolution why we want to go with the thing now. So we can just make with the these four level of the conversion, we will get the answer. This is one of the important question. And one more thing is what now? So we can just follow with the step process, that is very important. So in this example they are given like the direct statement. Okay, other than example, how we are going to just they are going to focus or some question paper it will be fall means. So directly they have given the some statement, we want to just convert with the FOL loop and then want to convert to the CNF. Okay, after that only we should just follow the steps. So this is called as a resolution. So in the generally we want to just make with the like true statement as a false and false statement as a true, just a conversion process happening like with the help of logical function and then CNF form. Yeah, thank you.